Hello class. I'm professor, teacher, PhD, and today we'll be learning about momentum equation in an isolated pipe. Yeah, you have to close the two ends, isolated. So, what is the momentum equation? The momentum equation relates back to Newton's second law, where it's a sum of forces in the system. So the two forces that we'll be dealing with in a pipe, specifically with water, is static force and dynamic force. Static force relates to pressure times area, force equals PA. Dynamic force relates to density times the flow times the velocity. Velocity we find with the velocity is the difference in initial velocity minus final velocity, and then you could find rho by getting the specific weight over gravity. Yes.
What's the difference between the static force and the dynamic force?
So static force is applied to a stationary object, or the water, and dynamic force is how much force needed to move the, say, object, and that's the difference.
Can you show an example of this?
Sure. So here's an equation that we have for an example of an equation for the momentum equation. So we start off with the static force. I'm going to just show you how units match up and everything equals to pound. So for static force, you got pressure times area. Pressure is pound per inches squared. Area is just inches squared. As you can see, the inches squared cancel each other out. You got pound, which is what force is. For dynamic, you got rho, which we did use a specific weight over gravity. So you have pound per feet cubed, and then feet over second squared. The feet cancels out, this one leaves it squared. Now you have QV. As you can see, the remainder of the feet all cancel each other out, and all the seconds cancel each other out. So now you have what's left is pounds, which is the unit for force. So now, like I mentioned in the beginning, momentum equation is the sum of the forces. So you just use the answers you got for static and dynamic, and you just add them together, and that's your answer for the momentum equation.
How do you know what direction it's going?
Well, as you can see, we're using our traditional x and y coordinate system. As you can see, the pipe is straight, so we're using the x direction, and it's going to the right. We're just assuming that all of our answers are positive. That means all the forces are going to the right. If the answer ever comes out negative, you're going the opposite direction, which is to the left. And there you go.